And that's when they call me up, just literally the day before we're gonna sign, and they say the deal is off. Thinking to myself, man, this is gonna be a great story one day if we survive, right?
So it almost sounds like that you were there when the opportunity knocked at your door, right? So
It's actually now up to 84 of the
info.
Fortune 100. Yeah, so we had a problem. We realized that the relational database wasn't the best fit. We were young enough and naive enough to say, you know what? Let's just invent something new here. How hard can it be? Right? And that is what led us to ultimately create what people today call the property graph model.
As an entrepreneur, you have built a company from scratch and you valued it around $2 billion. What is one founder challenge that you wish someone had warned you about?
The big thing that has changed, of course, in the last few years, what has opened up for all of us is operating on unstructured data. As part of that, one of the things that the team worked on was how do you take data out of a relational database and transform it into a property graph model?
So data quality and humans are still important, right? So
A hundred
it's not
percent,
going away anytime soon.
100%. Of course, we course corrected, but it took several years for me to understand that the core mistake there was this mismatch between strategy and resource. I think that's also how entrepreneurs are wired. We're not wired to listen to the system. If we were, right, then we wouldn't be entrepreneurs in the first place, right?
My guest today is Emil Eifrem. Emil is the CEO and co-founder of Neo4j. Welcome, Emil. It is great to have you.
Great to be here.
Okay. I was looking at your background and I bumped into on the Neo4j website, and I will actually read Change the World with Graphs and Own Larry's Yacht by the end of the decade. So first of all, is it Larry Page or Larry Ellison or all the rich Larrys in the world? I mean, so what is the background?
It's Larry Ellison, of course,
Mhm.
as the symbol of relational database dominance,
Mhm.
right? I figured, in the end, maybe I'll just own a rowboat, but I'm targeting the yacht.
Okay. So is there more symbolism to it? Is it like dominating graph databases like Oracle does for relational databases, or the actual yachts that he has?
It's my feeble attempt to be funny and not take myself too seriously in my bio. I hate these kind of bios that are all these kind of hero
Hmm.
descriptions and that kind of stuff. And in reality, I don't want to own a yacht, but
Okay.
I thought it seemed like a funny symbolism because on some level, what we want to do is usher in a new era of working with data that does not replace the relational database, of course, but is a good complement to it. So that's kind of the spirit behind the tongue-in-cheek bio.
Yeah. So are you on track for this KPI?
We'll see. We're only halfway through the decade, so so again, hope probably I'll only own a rowboat, at the end of the day. But we'll see.
And I don't want to turn this into a more of an exercise in KPIs and metrics, but I mean, you have some leading metrics as well. I mean, I mean, clearly you are, when we talk about graph databases, knowledge graphs, I mean, Neo4j is probably the first name that comes to mind, at least for me. I mean, that's my exposure to graph databases. So I think looks like that you're there, right? So you're making it.
Yeah, so I think we have the benefit of being kind of the OG graph database, so to speak, right? Like we coined the term way back in the days, right? And kind of I think, a significant role in defining the property graph model and then evangelizing it.
Hmm.
So I think it's fair to say that we're the most popular graph database out
Hmm.
there today.
But
And
Allegro was there when you came in. They did not call it graph database back then, or
yeah, there were several other kind of implementations of, call it the RDF world, right?
Mhm.
And we can get into the weeds of this, but just at a high level, like RDF is Resource Description Framework, and this was Tim Berners-Lee kind of second innovation after the first one being the web being this great system, of course, for human beings to consume through browsers. And then what he wanted to do in the late 90s, right? So way predating this agentic, here we are in 2025 kind of universe, right? But what he wanted to do is add a semantic layer to the more syntactic web. And he defined a format for that called RDF, Resource Description Framework. And it was the purpose of that was to describe resources on the web. And it has, like anything has pros and cons, but certainly lots of strengths for that kind of stuff. And then several people tried to take that and turn that into a database format. And I was always of the opinion that that was, some of the RDF technology was really strong, but it was not good as a database kind of foundation for a database technology because like ultimately it was a format for describing resources on the web. And so I didn't think that was a good fit. So there were certainly other databases that took a kind of a graph-ish view of the world, but they didn't call themselves graph databases, and they didn't use what today is the most popular graph model, which is the property graph model.
I read it somewhere that you came up with this sketch of a a graph model on a flight to Mumbai in year 2000. And uh, around that time, I remember those days, right? So I'm old enough to remember those days. These are the early days of cloud computing and big data, right? So Hadoop was becoming mainstream, and lots and lots is happening. So, what were you thinking? Because at that time, um, internet scale data, that's large scale data. It was, I would say, around Yahoo and some of those companies, barring those companies, it was not something very mainstream. It was starting to happen. So, can you take us back to how did you even think about that at that point in time?
Yeah, so let me kind of first tell kind of our story, and then let's relate that to what was going on in the rest of the industry and kind of the timeline for that kind of stuff, right? So our story was that, I joined a small startup in Sweden, didn't even know what the term startup was at the time, but I was a developer and I loved to write code, and pretty quickly became the CTO of that startup, and CTO and VP engineering kind of combined. So the 20-person, engineering team reported to me. And after a while, what we saw was that approximately half of that team, about 10 people, spent the majority of their time fighting with a relational database. And we were building kind of these multi-tenant SaaS offerings, but it was called different, like ASP, application service provider. And so we didn't have like that modern terminology for it, but that's what we were building, doing basically content management, especially around media assets. And it turns out that when you do that, you have a lot of connected data. For example, all the files need to sit in a file system with folders that sit in folders, which is a tree. But then we supported shortcuts, or in Unix, you would call them symbolic links. And all of a sudden, one file or folder could have multiple parents. And this is mathematical when a tree turns into a graph, right? And then we had this very sophisticated security model that we overlaid on top of that. So this all became like this really deep, complex web of connections that we tried to squeeze into square and static tables. And it worked. There's mathematical proof that you can model any data in the relational model. So you can do it, but it was like pushing a rope uphill. There's tons of friction. We had to do join tables and foreign keys here and there, and it's just messy, right? A combinatorial explosion that we hadn't really seen before. Today, I think anyone today would look at it, and today we have a crisp understanding in the industry, and generally, I mean, and we would look at that and say, dude, there's a mismatch between the shape of your data and the abstraction that you've chosen, the relational database. It doesn't mean that the relational database is wrong generally, but for this problem, it doesn't seem to be the best fit. But
Mhm.
remember, back in the early 2000s, really the only type of database that existed was the relational database, right? And so we banged our head against the proverbial relational wall for long enough that after a while we realized something is wrong here, right? And we started realizing that, wait, what if we had Oracle or Postgres or MySQL or Informix or like a robust, high quality database, but instead of a tabular representation, right, it would have nodes that are connected to other nodes, right? And then key value pairs, properties that you can attach to both of them. Holy crap. Then we can model everything. And that's kind of the thing that when you read the thing, like we grabbed this cocktail napkin. It was literally a cocktail napkin on a flight to Mumbai and like sketched out this thing. Now, of course, as any marketing message, that's a vastly simplified view. It's like it's back to the all these bios that are so heroic about whoever they're describing the individual, right? It makes it sound like it's all me sitting there in guru meditation position and figuring it all out. I had a minor part of it. It was a broad team effort. Your Indian origin. The reason I flew to Bombay was that I was going to IIT Bombay. So I had, several friends at IIT Bombay, which you would know is a phenomenal school, and they played a huge role in figuring out this model. But ultimately, we had a problem. We realized that the relational database wasn't the best fit. We were young enough and naive enough to say, you know what? Let's just invent something new here. How hard can it be? Right? And that is what led us to ultimately create what people today call the property graph model. So that's kind of our origin story. And now what was going on kind of in parallel, because you related it to the rest of the industry. This actually predated Hadoop, right? So let's think back like early 2000s, right? Google had just been founded. Yahoo was around. Hadoop didn't exist yet. Google was starting internally to use MapReduce, but they hadn't spoken publicly about it. And the discourse in the industry was that the relational database is the end all be all innovation of data. There may be data innovation on top of it, but it's like a mathematical axiom. And this was a lot of the scar tissue from in the mid 90s. There had been this surge of object databases, right? That was going to take out the relational database, those kind of things, right? But they failed. They went out of business. Well, at least they grew to maybe 10, 20, $50 million of total revenue, right? And ended up like going into obscurity. So I think a lot of the discourse was that the relational database is going to be there forever, right? But inside these web companies, they were also running into another version of the problem that we ran into, primarily driven around scale. And this really ended up becoming more of a public thing in 2006 when Amazon published the Dynamo paper. And they said, hey, folks, we want to sell books because at the time they were primarily or maybe even exclusively an online bookstore. We
Mhm.
want to sell books, right? The last thing we want to do is build our own database. But sadly, all the off-the-shelf databases don't work for us. So we've been forced to invent our own. We call it Dynamo. Here's how it works. And just a few months later, 6 to 9 months later, Google published the Big Table paper, which said, hey, we're Google. We're also handling some amount of scale. We also were unable to get there with the off-the-shelf tools from the Oracles and the IBMs and whatever of the world. So we also invented our own database. We call it Big Table, and here's how it works. And those two papers was like they were like a lightning strike. And all of a sudden, the world, well, a few alpha geeks really, but started talking about, wait, the relational database may not be the only solution for all of data.
And I think this dissatisfaction started to happen with relational databases around the time when we started handling internet scale data, right? So I was talking to Amar Avadallah a
Of
while
course.
back on the same podcast, and we were discussing, and he was telling us um, back during his time at Yahoo, they would I think he was part of the advertising or some team that was responsible for running online ads, and then a single query would take them days to run um, uh, on Oracle, right? Back then, and then early proof of concepts of Hadoop. and this NoSQL world, it suddenly drastically cut the query time. So yeah, so yeah, that's interesting. Thanks for the background here. And now a lot of companies. Once again, I was reading while preparing for this podcast that 75 out of the Fortune 100 companies, more than 75 of them, they use Neo4j, right? So what are some typical use cases that you see for graph databases, knowledge graphs, property graphs?
It's actually now up to 84 of the
84.
Fortune 100. Yeah, so we're
So who
moving
are
up
the
in the world.
16
Yeah,
that need to be there?
exactly, right? And it's very horizontal, like across all verticals that I know of. So every single one of the 20 biggest banks in the US are now customers. Nine of the 10 biggest pharma companies in the world, 10 out of 10, the 10 biggest car companies in the world, eight of the 10 biggest retailers. And I could keep going, insurance companies, 8 out of 10, and so on and so forth, right?
Mhm.
So it's very, very horizontal technology. In terms of use cases, I would break it down in two broad buckets. One, the first one I would call intelligent applications. So these are applications where there's a lot of value in not just retrieving a singular data point, like you store something and then you retrieve exactly that back, but you actually figure something out in the data, right? Like, for example, there's a fraud ring here, right? There's a lot of individual transactions that seemingly are okay individually, but they're connected in a fraudulent way, right? Or a customer journey, like analyzing what's the journey, what's the path of an individual customer, starting with some advertising campaign that maybe goes to the website, maybe they visit your app, maybe you have an offline store, like they go to the store, maybe they talk to your customer service center, right? Like how do you trace that entire path, right? So these are what we call intelligent applications, and they break down into what we talk about the seven graphs of the enterprise, which is graphs like the graph of your employees, the graph of your transactions, the graph of your products, the graph of your customers. And there's a bunch of use cases hanging off each and every one of these. So that's the first category, intelligent applications. The second category is what's happened over the last couple of years, right? Which is this surge of adoption thanks to the amazing fit of knowledge graphs and AI. And that
Mhm.
really doesn't break down into like use cases per se. It really is anywhere where you have your own organization kind of internal proprietary data, and you want to marry that up with an LLM, right?
Mhm.
And then you use a knowledge graph as a way of efficient and powerful way of giving the LLM access to that data. So those would be the two broad buckets with lots of use cases inside of the first one and very horizontal applicability in the second.
So I was going to ask you about knowledge graphs and AI later, but since you mentioned, so it almost sounds like that you were there when the opportunity knocked at your door, right? So because I'm having built agentic AI systems myself, I actually clearly see why a knowledge graph is so helpful. But for anyone who does not understand out there, why do you think knowledge graphs are going to be helpful in building agentic AI systems? I mean, how do they? There's this, we read about this a lot that knowledge graph can help minimize hallucination. So if you can give us a sense, why do you think it is the case?
Yeah. So there are three core benefits that we see that our customers keep telling us over and over again, right? And most people value all three, but they're kind of individually weighting of the three. So let's go through all of them in order. The first one is improved accuracy. And this of course is another way of saying reducing hallucination, right? And if you think about kind of the classic agentic RAG architecture, right? You have ultimately a human being, not always, but let's assume for sake of simplicity, there's a human being, right? And maybe let's do the classic customer service support portal, type use case just to keep it simple, right? And so you have Raja is asking a support question about a product that he just bought, let's say a Wi-Fi router or something like that, right? And then you want your agent to understand that question in text, or maybe it's voice, maybe it's like, whatever, but ultimately get to that agent in text, right? And then the job of that agent is to look at the corpus of 10,000 or maybe 100,000 support articles, find the top K, which is like a pretty small number, like 10 or 20, not like 1,000, right? Let's say it's 10. Find the top 10 support articles that are most likely to answer your question about your Wi-Fi router, right? Hand it off to the LLM along with your question, and then say, okay, does this answer my question? And then, of course, in agentic RAG, then there's like a loop, but anyways, but that's kind of the single pass,
Mhm.
single tools kind of simplified view, right? Okay, if you think about that problem, right, it turns out we as humanity, not Neo4j, humanity, we've actually solved that problem before. And you and I, we ended up talking a lot about history here in the beginning, at the top of the podcast, right? You think back to the mid to late 90s, there were actually dozens of search engines out there. Lycus, Excite, Yahoo, Alta Vista, a bunch of them, right? And they all did basically the same thing, which is they did some kind of inverted index type search, maybe BM25, like some version of that type
Mhm.
text search on individual documents on the web, right? And then, of course, along comes a small startup, Google, obviously, which says, we're going to do that, what you guys do. But on top of that, we're going to rank the search results based on the links on the web, right? We're going to use a
Mhm.
graph algorithm called eigenvector centrality, but they modified it for the web, and they, of course, famously called it PageRank, right? Powerful graph algorithm. That results in the top 10 blue links, right? And I was very active on the web in the early mid 90s, right? The problem was the Alta Vista problem. You search whatever you search for, you got too many search results, and the
Mhm.
relevant ones was like page 77 or something like that, sometimes, frequently, actually, right?
Mhm.
And Google just killed that. And so it's exactly the same problem. Look at the big corpus of information, find the top 10 most relevant documents. So a graph turns out to be a great way of doing that, which is why there's so much research showing that accuracy with graph RAG. So if you use a knowledge graph in combination with vector search, right? That's a much more accurate, gives much more accurate responses than vector only RAG. So that's the first benefit, improved accuracy. This one is intuitive once you think about it from that perspective. But the second one is very counterintuitive to a lot of people. So we first saw this when one of our first customers, which is a company called Klarna, that many have heard of, and they're one of our first customers for AI. And they had written this application internally on top of a vector database. And then they started exploring Neo4j. And so they ported that application onto Neo4j. And I still remember the Slack message that Sebastian, the CEO of Klarna, sent to me saying, from one of his engineers saying, holy crap, just by virtue of porting it from a vector database to Neo4j, we've found a bunch of bugs already. And why is that? It is because if you think about vector space, like in vector search, I'm a big fan. We support vector search in Neo4j. It's very powerful. But vector space is ultimately opaque. If you have two objects, right, at least these two things, and you ask how similar are they, right, then you're going to get maybe these are not that similar. So like zero point 0.4, you're going to get back, which is some
Mhm.
cosine, your Euclidean space calculation, type thing, right? If it's an apple and an orange, it might be zero point 0.6, but you don't know why, right? If
Mhm.
you marry that up with a knowledge graph, you know that an apple and an orange, they're related because they're fruits. An apple and a tennis ball might be very semantically similar in vector space, right? But if you marry that up vector space plus a graph, then all of a sudden you can say that no, it's because they're round and because they're green, for example, right?
Mhm.
And so all of a sudden, graph space is explicit and visible, vector space is opaque. So when you write your application on top of a knowledge graph, instead of just a vector database, you see your data, and that leads to people being able to build applications faster and find bugs faster, and stuff like that, right? So that's the second benefit. And then the third one is like the other side, the flip side of the coin of the fact that graph space is explicit, which is it's also explainable. In back to the example of customer service portal, like why did you choose exactly these top 10? Well, it's because well, I guess Raja, in this example, you were the end user. So Emil, the great support engineer Emil, wrote these, like some of these, and he's highly ranked, right? Many people approve his answers. That's why I chose the top 10. So that gives explainability, especially if you marry it up with some of, Anthropic has done a lot of fascinating research around interpretability and visibility into the LLM, right? So you have both of those things. You have an explainable AI system, and it's also auditable. And the banks, regulatory, whatever, insurance companies, government, like they love that. So higher accuracy, improved developer productivity, and then explainability and auditability. Those are the three core benefits of using GraphRag, using a knowledge graph on top, or instead of just using vector search.
I was going to actually mention explainability here, right? So do you foresee, or maybe you already have things that some kind of explainability tools built in when I'm building an agentic AI system and where I have some regulatory requirement, or maybe my application, the domain requires my solution to be explainable. Do you have anything that is built in within
Yes.
knowledge graphs that will, if I got this response from my agentic AI system, or if a certain decision was taken, depending upon what kind of agent I have, um, I'm able to explain it. Do you have any such thing?
Yes, we have a plethora of tools available, and some of them are like command line tools, like the equivalent of like explain in Oracle or Postgres or something like that, where we'll kind of explain the query paths and stuff like that. But I think maybe the more powerful ones are visual, right? Where you can go in and you can actually see the query path, you can see how it traverses through the graph, right? And through that, understand why it chose this particular document and hand it off to the LLM, right? So it's those types of tools that people tend to use.
Mhm. And you earlier, I think the second point that you were mentioning, contrasting it with the semantic relationships, you gave this example of apple and orange. Um, do you see this? It is going to be problem specific, that certain problems they require knowledge graphs more than other, or you always, is it complementary to semantic, your classic LLM based approach versus LLM plus knowledge graphs any day? So let's say I'm an agentic AI developer. Let me rephrase the question. If I am building an agentic AI system, should I plan my system to ground up? It is always going to be this knowledge graphs, entity, property relationships, plus the semantic relationships using this model, LLMs, or it is going to be on a case-by-case basis. For some problems, do this. For other problems, have both.
Yeah, I don't think there's any technology that is the silver bullet that you should apply across the field anytime. What
Hmm.
I will say, however, is that there's a broader trend, I think, starting to become well recognized. It's not quite there yet, but people are starting to pick up on it. In that, in order to build truly production grade agentic AI systems, not the toys, not the proof of concepts, right? But production grade, in particular in the enterprise, right? Or at startups, if it's mission critical for that startup, like so if it's your main product. For those kind of situation, you better invest upfront in your data,
Hmm.
right? And that can be produce a knowledge graph so that downstream you get higher, kind of better retrieval, recall, better, higher accuracy, right? And easier to build your application. All the benefits we just talked about. But yeah, I do think that sometimes the way to do that is you extract some structure in your ingestion pipeline, and then you do people in kind of vector database land tend to think of it as metadata filtering, but it really is marrying up the semantic unstructured search with structured data, right? And I think sometimes for the low end use cases, maybe that's enough. Certainly, it's powerful and easy to get started. When you're just playing around, most people I don't yet spend enough time upfront on prepping the data and on their ingestion pipeline. They just want to do something simple to throw it in there. And then I think like kind of vector only approach is fine to get started. But for many of the real production stuff, you better invest in that ingestion pipeline, and creating a knowledge graph is one of the most powerful representations that will certainly help you downstream in many scenarios.
Okay. And using something like a knowledge graph or property graphs, there is some investment in terms of, so if I need a semantic relationship engine, let's call my LLMs, I have them available off the shelf. Now, then keyword search has been around for 25, 30 years now, BM25, TF-IDF, all those. I mean, they have been around for a while. Then knowledge graphs have been there for a while, right? So I see something called hybrid search now. So hybrid search is available off the shelf. So do you have some version of like hybrid search 2.0 where keyword, semantic, and knowledge graph, they're available like at the same time, right? So, and I
Yes.
don't
No,
have
I think
to, as a developer, I
totally.
don't have to worry about it.
Yes. So we do that, and so that's available out of the box from Neo4j today. Now, our vector search is very good, but it's still early days in terms of scalability, right?
Mhm.
And so what we say is like for the high-end use cases, we actually recommend that people go with the Neo4j for the knowledge graph and a dedicated vector database. This is if you
Mhm.
have, call it 500 million embeddings or a billion embeddings or something like that, right? For if you have a million, if you have 10 million, if you have 50 million, it's easier to just get started with the built-in vector search that we have, which by the way is Lucene based, right?
Mhm.
And we've had Lucene for our keyword search
Mhm.
for 15 years, right? So we have a lot of experience in kind of,
Mhm.
bundling that and making
And
it
Lucene
work
now
in
supports semantic as well, right? So,
exactly. Yeah,
yeah. Hmm.
that's exactly right.
Okay. So you have something that is best of all worlds, right? So semantic, graph, keyword, all of them at the same time.
Yes, that's
And
exactly right.
what about your integration with, mainstream vector databases or mainstream developer stacks or frameworks like LangChain, Olama, and all of that? I mean, do you have that going
Yeah.
on too?
So we have great integrations to most popular frameworks. You can never cover the entire long tail, but this is one of the benefits
Hmm.
of being the most popular graph database and having a big community and all that kind of stuff, right? So there's lots of integration. And the same with many vector
Hmm.
databases. There's patterns, there's connectors, and that kind of stuff, right? So we're in a pretty good spot there, I think.
That's great. Um, so you mentioned you are up to your score is 84 out of that Fortune 100 companies, right? So let's say I'm the CIO of the rest of the 16
The
companies.
16, yeah.
Yeah, remaining 16 companies, and they want to stay in the relational world, and at best, I mean, they want to stay in the NoSQL world. How would you help someone who has a technical background? I mean, why should I care?
Yeah, so I don't think you should care just because the data model is nice or offers some benefits or something like that. It has to start with a business problem, right? And the business problems tend to come in one of those two broad buckets that I said, like intelligent applications, of which there are many. There's probably hundreds of those use cases right out there, in fraud detection or personalization or digital twin or supply chain analytics or product recommendations and so on and so forth and so on and so forth, right? So there's ton over there. Or the broader notion of, you know what? In order to do AI properly, there actually is a big trend. And you said CIO here. And so with the CIO, I would speak to it differently than the individual developer. To the CIO, I would say, look, most successful AI applications today, they are using exactly the same pattern. And you see it under the hood almost everywhere, which is I'm going to sit on top of several disparate data sources. I'm going to read them into some intermediary format, right? Which is not your core data platform. It's not Snowflake. It's not Databricks. It's not BigQuery, because most agentic applications require low latency, more real-time requirements. Not all, there are some batch agents, but most require that low latency that those core data platforms can't do. And so people read it into some kind of an intermediary representation, and then they layer their agents on top of that.
Mm.
And it turns out that the property graph model is a really powerful way of expressing that information. This is why, if you look at, again, this would be how I would speak to a CIO, right? If you look at the big tech vendors out there, we're recording this Thanksgiving week, so end of November. Last week was Ignite. Microsoft launched Fabric IQ, which is their graph-based, they call it the semantic intelligence layer. We tend to call it a knowledge layer, but it's the same thing. It's a graph-based way of sitting on top of your multiple data sources. Get them in this graph-based format with an ontology. So with a schema, let's say. We can talk about ontologies later on if you want to. And that is how you build best-in-class agents. That's the Microsoft story. The ServiceNow story, to pick another tech company, they, a couple of months ago, launched their big bet on AI called AI Experience. In their blog post when they launched that, Amit Savari, the chief product officer and president of ServiceNow, he wrote about the top three differentiators of the AI experience. The number one of them was knowledge graphs, right? Salesforce, to pick a third example, Salesforce is now hiring for a VP of knowledge graphs reporting to the chief data officer, right? And so there's this big trend going on right now. Everyone is independently concluding. People who don't have a horse in the graph race like I do. Of course, I'm the OG graph guy. I'm always going to be graphs, 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 right? But lots of people who don't have a foregone conclusion that graph is the right solution, right? Have independently come to the conclusion that, dear CIO, the best way to write enterprise-grade, robust AI agentic applications is to use this graph-shaped layer, semantic layer, or a knowledge layer. And that is why you should care about graphs.
Mm. And is it done, how do you foresee it, right? So do you think that organizations will have an organizational level knowledge graph of all the relationships, and then sub-organizations within the company? So there is some kind of the steward, as we call it, right? Some kind of top level administrator of the knowledge graph. Is that how you anticipate
Great question.
organizations are going to be using it?
Yeah, so it's a great question, right? Because it's about like, okay, great. If that's the theory, in practice, how do organizations adopt this, right? Because theory in
Because
practice,
taxonomy also matters, right? So no two
totally,
organizations will have the same knowledge graph, right?
totally, right? We see two broad patterns here, and they roughly break down per size of company,
Mhm.
right? One is exactly what you said. It's like, all right, people tend to call it an enterprise knowledge graph, which is it replicates parts of the data that sits in their core data platform. Remember, like the industry have now spent, call it 5 years, moving their data. You mentioned Hadoop before. That was kind of the V1 attempt at this, which ultimately didn't work out, right? But now with kind of the data lakes and the lakehouse patterns, right? Um, People have now moved most of their data into these massive modern data platforms, right? And so then it's like, okay, I want to replicate part of that data into a graph form in my enterprise knowledge graph. And then I hang these, you know, concrete, intelligent use cases or AI agentic applications on top of that. That's one pattern. But the much more common one, that's usually smaller companies. The much more common one, and the one that I always recommend for like I guess your framing of the question was the 16 of the remaining of the Fortune 100. So by definition, these are massive, massive companies which have many divisions that in and of themselves could be like as a big company, right?
Mhm.
And so I always recommend that you need to start with a business problem solved by an AI application, which might be composed of one or multiple agents and all that kind of stuff, right? And then let that application drag the data in. So what that means is, okay, for that application, solving that particular business problem, maybe it needs to sit on top of my sales database, my kind of customer success database, and a weather database, for example, right? Because I want to do some forecasting based on weather forecasts and stuff like that, right? Just making something up, right? Okay, then the initial thing is like, let's put that in a knowledge graph, like those three systems, right? And then you incrementally build it out over time as you add more and more applications to it. Generally, one of the reasons that Hadoop failed, one of them, there's plenty more, but like one of the key reasons was that the entire notion was I'm going to first take all my data, dump it into Hadoop, and then later I'm going to get business value from it, right? And I think that generally is an anti-pattern.
Yeah, and also I almost, as you discuss, as you explain, and thanks for very clear explanation. So, and I come from a technical background. I build these things. So, but the kind of insight that I'm getting is, we in data science, machine learning, and now agentic AI, domain knowledge is something that is going to be incredibly, incredibly useful. And many times the failure happens not because the system failed, it is just that the domain knowledge was simply not there. So I see knowledge graphs as more of a central curation of the domain knowledge, right? So all the relationships between entities and concepts and ideas. Um, in case the agentic AI it doesn't know which way to go, it it just steers it in the right direction.
Yeah, I think that's spot on, right? Like you have your fragmented data landscape, and that's true for any non-trivial size organization. And then you can get those individual pieces using some kind of a tool in your agent. You could call it drag, you can call it whatever you want, right? But if you have a layer that knows that these suppliers are connected in the following way, these products are related, these are the product hierarchies. This is an airplane engine that in turn consists of thousands and thousands of parts. Those parts in turn consist of thousands, well, maybe hundreds and hundreds of parts, right? And then you have the supply chain connecting that. If you have that view, the agent can make sense of that fragmented individual data element in a much, much better way. And that ultimately is what's needed to create real, robust, enterprise grade agents that solve real problems.
Yeah. And is there a common misconception that you hear about when to use graph databases, or what are they and when to use them?
Yeah, probably the most common one is around the niche nature of graphs. That graphs are good, but really just for some little kind of corner of the world. And I see that changing rapidly with AI, where people start realizing that, well, whenever I have internal information, there's a great chance that the best way of expressing that information for like towards an LLM is through a knowledge graph, right? But I still think that most people think of it as kind of this smaller niche technology. So that's probably the number one misconception I would think.
And the process of creating a knowledge graph for a given organization, it is still uh, in a machine learning sense, it is more supervised. You have to have some domain expert who actually figures out these rules. They understand the rules. Um, do you see that it is with LLMs and agentic AI, maybe with usage? Um, it could either be using LLMs itself, AI itself, or maybe some kind of feedback loop, that this can become a semi-supervised or almost automated process that as the organization matures, this process of construction of knowledge graphs, it becomes, or maybe improvement of knowledge graphs. You start with a very basic primitive knowledge graph, and eventually it becomes a complete knowledge graph. An answer was upvoted. Let's figure out what rules can we infer from here. Do you see something like this happening?
Yeah, it's a great question. And let's just start with kind of being intellectually honest. One of our core values at Neo4j is intellectual honesty, right? Remember, I talked about the three benefits of using knowledge
Hmm.
graphs for agents: accuracy, developer productivity, and then explainability and auditability.
Hmm.
The number two benefit there, developer productivity, is true. We see it every day. We hear it from customers. But back to the intellectual honesty and rigor, it is only true once you have the knowledge graph, right? And so you're exactly right to hone in on this part. Like, how do you get it in the first place? And I think what's happened here is that this used to be pretty easy, right? Because all the data that we operated on was structured, right? And still people were like, okay, how do I do, like everyone knows how to do OR modeling. We're taught that in school. And if not, there's plenty of people around us, like if you're any kind of developer is
Maybe if I want to be a
learn
contrarian, I mean, there are very few people who know how to do it well, right?
to
So,
do it well. This I completely agree with, right? But you can get your application up and running relatively easy, right? And model it in a relational database, right? And you might need a little bit more help with a graph database, but it's still structured data, right? And one of the things that we've spent a lot of time on is a little bit of a kind of sidebar here is the GQual language, which is the first time that the SQL committee approved a new language for databases in the history of software, right? So for 40 years, we had only one language for speak, a standardized language for speaking with databases, SQL. Now we have GQual, a sibling language to SQL, which is governed by the same ISO committee. And it is 95, I don't know, 98% Cipher, which was, of course, invented by Neo4j. Super proud and love that. As part of that, one of the things that the team worked on was how do you take data out of a relational database and transform it into a property graph model? These data models, by the way, are all isomorphic, right? So which is a fancy way of saying that you can take information in one of them and transform to the other and back without any loss of information, right? And so there's this notion called tables for labels. So if you have a person table, that means you're going to take that and translate that into nodes with a person label. And every column in that person table will be a property key on a node that has a person label, right? So there's actually a very simplistic process from going from a relational schema into a property graph model. But so why did I say that I thought your question was really, really astute? Because the big thing that has changed, of course, in the last few years, what has opened up for all of us is operating on unstructured data, right? That's ultimately one of the L's in LLM, is language. It's text, right? And so now all of a sudden, what the challenge is how do I go from unstructured data, let's just simplify it and say it's text in PDF documents, and how do I create the graph from that, right? It turns that LLMs, exactly as per your question, is a great first step towards that. But the notion of just throwing any random PDF to an LLM, one shot conversion with no additional information, it will create the knowledge graph for you. And initially, it'll look good. It'll be a little bit like if you just dump your data into a vector database, you don't care about chunking, you don't care. It'll kind of work. And again, for that toy POC, it'll work. But it won't really work when you put it in production and you want real accuracy and that kind of stuff. And it's a little bit the same. What we're seeing, though, that if you provide just a little bit of hints to the LLM, about the domain, back to your comment about how domain expertise is becoming increasingly important, right? If you tell it that these are not generic PDFs, this is about a healthcare project with the following kind of key principles, or this is oil platform maintenance document, or whatever the domain might be, right? Then all of a sudden, it gets to this instead of call it a 60% valid knowledge graph, it moves to in the 90s, right?
Mhm.
So all of a sudden, you get a much higher quality knowledge graph out there. And so that's a big part of what we're working with our customers to do in their ingestion pipelines.
So data quality and humans are still important, right? So
A
they
hundred
are not
percent,
going away anytime soon.
100%.
Yeah. Um, so I can continue actually discussing knowledge graphs and spend an entire day here, but I had a few other questions
Sure.
unrelated to Neo4j knowledge graphs. As an entrepreneur, you have built a company from scratch that is it is currently valued at as according to public information, you're valued at around $2 billion.
Yeah. Yeah.
Um, so what is one founder challenge as someone who has started from scratch and now you're market leader in one particular area? Uh, what is one founder challenge that you wish someone had warned you about?
Man, that's a good question. There's lots. Obviously, there's a long list to choose from. Um, Maybe what I'll talk about is so I think many engineers, I'm obviously kind of developer by background, and I think we're wired to be relatively analytical about the company building process. And maybe other people might be more instinctual, but I'm certainly more kind of on the analytical mind, right? And so I think what that led to was that in the early days, we ended up with what I still today believe is the right strategy on the go-to-market for a company like us. And that strategy was win the hearts and minds of developers. That is why we are open source. That is why we go to all these conferences and meetups and like all of that kind of stuff, right? And we have a free tier of our cloud service, like a free forever tier, right? All of that is to win the hearts and minds of developers everywhere, right? And very powerful. What I did in the early days, though, right? Back in 2011 when we raised our Series A, then we were, I don't know, a dozen people or something like that. It was basically myself, one of my co-founders who was like a DevRel-ish type person, and then 10 engineers, right? But a year later after our Series A, we were like 50 people and maybe like a dozen engineers or 15 engineers or something like that. We built an entire enterprise sales go-to-market organization around the still very embryonic engineering organization and very early product, right? And obviously, part of that was fantastic. That is when we started the march towards the whatever 84 out of the 100, started winning like some of these big logos. And you need enterprise sales to do that. Like PLG won't get you there. Not for the real deal sizes, not for the mission critical stuff, right? Though I love PLG, it's a good compliment. But you got to have real salespeople for that kind of stuff, right? And so that was positive. But if the go-to-market motion starts with winning the hearts and minds of developers. So for example, when we entered into all these 84 out of the 100, we didn't go and knock on some door and talk to the CIO. I didn't talk to any, for the first 10 years of the company, didn't talk to a single CIO. Now we have tens of applications, sometimes 50 to 100 applications in production with these massive companies. That's when I talk to the CIO and I say, hey, dude or dudette, right? Let's try to rationalize this. You should have a center of excellence. We should have an enterprise consumption agreement and all of that. I have a strategic conversation with them, right? But initially, we entered in through the developer. Okay, so what's what's the one kind of mistake? And again, there's plenty to choose from, but the one that I choose to talk about here that I wish someone would have told me is that I did, I had the right strategy, I still believe, for the company, but there's a mismatch between the resourcing and the strategy. 10 or 12 or maybe 15 out of the 50 were engineers. And the problem is, if you want to win the hearts and minds of developers, how do you do that? By creating a low friction product experience, super easy to install, easy to get started. That's a product game. That's developer, that's DX, right? And packaging and that kind of stuff, right? And your very strong enterprise salespeople won't help you with that, right? And so in that, and of course we course corrected, but it took several years for me to understand that the core mistake there was this mismatch between strategy and resourcing. So that probably would be one out of many mistakes that I would tell my younger self not to do.
Okay, yeah, that's great. And there is just way too many things, right? Your GTM plays a role, your sales, enterprise sales. But what if they go and sell and the product has friction in it, right? So, and it doesn't add value, or maybe it adds value, but it is too difficult to use, right? So, I think it's a fairly complex game, and a lot of things you can only understand if you've been through it, right? So, a lot of
In
things
hindsight.
in hindsight, right? A lot of this is hindsight. Um, as an entrepreneur myself, I mean, many things that I can relate to now, I know someone told me like many years ago, but I had to run this course. I had
Yeah.
to
Yeah.
experience and fall
Yeah.
down,
Yes.
not just once, a few times until I internalize this is how it works.
I think that's also how entrepreneurs are wired. We're not wired to listen to the system. If we were, right, then we wouldn't be entrepreneurs in the first place, right? And so I think like some of it, exactly to your point, you just have to live through yourself, which is why we all have a bunch of scars on the back of our, but that's part of the game. That's what makes it fun.
Yeah, and another thing that is very common among entrepreneurs is near-death experiences, right? So, no one knows, and you don't have money to run the next payroll, right? All of that. Anything that you can share publicly?
Yeah, we had a like an early near-death experience, right? Before we'd raised any money, and we were, uh, you know, two founders, on the payroll but not taking any salary, and then four other people, and we were kind of funding the company through like consulting a little bit, and we'd raised actually like a really small kind of angel round. I want to say like 150 to 200K or something like that, right? So it's very little, but there's um, some kind of investment into the company. And then we were about to raise our seed, and we got a term sheet from, this is when we were back in Sweden, right? But one of the best investors in Europe, like very kind of credentialed. And they gave us a term sheet around Christmas time. And then we signed it, we started this DD process. We had $30,000 in the bank when we started. And you know how this goes, like the company pays for kind of lawyers, and there's kind of accounting. It was like the company was like nothing, but still some amount of accounting DD, and looked into the IP and like an FTO, freedom to operate, like a patent thing, and stuff like that. And so by March, when we were about to sign, we'd burned through like all of our cash. We had like nothing and $2,000 in the bank account. And that's when they called me up, just literally the day before we're gonna sign, and they say the deal is off. We're gonna walk from the term sheet. And and I remember looking at the bank account, it's $2,000, and it's 6 days to payroll, right? It's March 19th. Yeah, I remember even back then thinking to myself, man, this is going to be a great story one day if we survive,
Yeah.
right? But
Yes.
obviously we did survive. So what we ended up doing was, I got that. It was like a Tuesday, I believe. I got the call in the morning. Instead of getting on a train going up to Stockholm to sign the papers, I still called the team. We got back. It's like, all right, this is the deal. They just walked from the term sheet. We got to do something. We ended up, I called all my friends in the industry. We sent people out to consulting, right? To do consulting, not even on top of Neo4j, just anything, right? Just like software developers. Um, I convinced the customers that I could send an invoice right away, right? Ahead of time. And then I took those invoices and I sold them to a factoring firm, it's actually generally like not a good deal. Like if you have an invoice for $100, you sell it to them and then they give you $90 right away, and or $80, right? And then, obviously they make the balance,
Mhm.
$20, for example, right? And so it's obviously a shitty deal, but the benefit is to get the money right away. And so we did that in a few days to just get money. We made payroll kind of the following week, and then we started kind of funding the company that way. So it should have killed the company, but the team was so committed. This is like the early team. Like this is when people talk about founders. Yes, founders are so important, of course, right? But man, like that early team have so many founder-esque qualities, and I remember them saying like, "No, this is too good. We can't let this die because of this, right?" And so they went out and did like boring consulting, doing like that's not what they were sort of join Neo4j, not to do like some consulting thing, right? But they did that just for us to get cash flow. And then, after a while, we took one of them home, two of them home, started building the product. And then subsequently, like 9 months later, something like that, no sequel had happened. Through the hype of that, we ended up racing a real round, and then we were off to the races.
It is amazing. I've talked to many founders, and pretty much all startups, or most startups actually, they have a very similar story, right? So you have some early people who believed in the idea, they stay with you, you're running out of money, some help comes in, consulting, borrowing from friends, whatever it takes, right? But you just have to survive. I mean, you have no other option. So
I
it
I think
is
I think you
fascinating.
nailed it with whatever it takes, right? If
Whatever it
you
takes, yeah.
gotta have that mentality, and if not, you're just not gonna survive.
Yeah. Yeah. And how important it is for a startup to um, proactively manage the culture, and maybe and invest in people and make sure that you don't get the right people. So I think it's all part of the culture, right? So do you actively at Neo4j, do you invest in culture, the
Yeah,
mindset, some cultural values?
yeah, yeah. This could be like a 2 hour test in of itself, right? Uh, um, it is always absolutely crucial, but the tactics and the techniques vary significantly at stage, is what I've found, right? Like, so in the early days, it is basically through hiring. Who do you hire and who do you not hire? And then through what behavior do you model? Those are the real way. Yes, you can write shit down on something, but like that's the real way that you end up shaping your culture, right? And when you're 5, 10, 20 people, it just happens through osmosis because you're in it, you're together, and everyone is, it's a, what we in the graph world would call it's a fully connected graph. So every node has a relationship to all the other nodes. It's a fully connected graph, right? At some point, that breaks down. And it is actually a cultural trait is when does that break down? And when do you start becoming a little bit more hierarchical? And, we have all heard of Dunbar's number, right, which is around 150, which is how many people can you actively kind of keep in your head at the same time and have an individual relationship with, right? And if you're geographically distributed, that adds more complexities too. But at some point that's going to switch. Typically it tends to happen between 30 and 50 is what I've seen, right? And that is also around 50 is when it happened for us, when you need to, like, again, the tactics and the techniques shift. You still need to role model behavior. You still need, like, hiring is maybe the most important one, or at least very high on the list, right? But that's when you need to start becoming more explicit around writing things down. and you need to have mantras. Like one of our, like, we have six core values still at Neo4j, but like one of the mantras that we had that I talked a lot about was building an American company with a Swedish soul, right? Which people tend to love that, but like no one knows what it means. So then, like I have a little bit of a lecture about what it means, which I'm not going to go into
Actually, I
here.
get it. I
Yeah, yeah.
absolutely get
Okay,
it,
good,
and I
perfect.
love it. Actually,
Yeah,
I
it's like that.
immediately get the references that you have there. So yeah,
Yeah,
I get it.
and so that's like one technique then of like tying your cultural traits and attributes to something when people don't see you day to day anymore. But again, when you're 15 people, that's not needed, right? Because they have so much surface area with all of the employees in the company, right?
Mhm.
And so on and so forth. And then like, now we're about 1,000 people, so now there's plenty other things that you have to layer on top of those different things, right? Yeah, but to your question, it is always like important.
And has it ever happened that you hired someone and then you realized, oh, well, we have to protect our culture for whatever reason, maybe not consistent with being an American company or someone who comes in and takes away that Swedish soul out of Neo4j. Has it ever happened?
Oh, many times, right? Where it's like, okay, this person has the core skill sets for the job, but the way they interact, the way they show up, the way they treat their colleagues or treat their customers or prospects or partners is just not consistent with how we want to show up, right? And then there's only one way. Like you have to take care of that. Otherwise it falls apart. And again, we have six core values. The first one is kind of first among equals, which is very simple. It's just three words. And those three words are we value relationships. That's it, right? And people think that we have that value because we're graph people, but it's actually the other way around. We've built the graph database because we are people who value relationships. We value the relationships between our employees. We value the relationship between us and our stakeholders, like investors, the relationship between us and our customers, us and our community members. We also value relationships in data. And people who value relationships in data, if they're building a database, they will end up building a graph database, right? And so if you show up in a way, if you behave in a way that doesn't value relationships, for example, between you and your colleagues, you have to take care of that. Otherwise, the culture deteriorates.
And it encompasses a lot of different aspects, right? So relationship within the company, and of course, customers are all about relationship. Partnerships are all about relationships, right? So
Totally.
managers with their direct reports. I think I love this one too, right? So that's very spot on. Okay, so one last question before we close. What are you most excited about as Neo4j in terms of a leader in knowledge graphs, graph databases? What are you most excited about?
It actually is what we kind of discussed before when you asked me what would be kind of the CIO level pitch to close the
Mhm.
gap between the 86 to 100, right? So in other words, we have gotten to like where we got started, like my full scope then was the scope of a single application. And my focus was how can I make it better for initially developers and then ultimately data scientists in in pursuit of solving a particular problem, right? Expressed typically as an application, right? And then what's happened over the last several years has been many of our big customers, again, they have tens of applications in production, and they start seeing data network effects and use case network effects. So they might have started with like a supply chain visibility application. And the team there purely looked at it, what would be the best database backend so that I can have visibility if the Suez Canal gets blocked for a week, like it was a few summers ago. What is that going to do to my global supply chain? Or run what if scenarios, root cause, and that kind of stuff, right? And they looked at the graphs, they believe that was the best fit for that particular application. Okay, that's great. Completely independently, there's another team doing personalization and recommendations. And they say to express my product hierarchy, the best way to do that is with graphs, right? Okay, so that all happened kind of independently. But over the last few years, they've started talking and they say, wait, what if I connect these two graphs? And we're pretty good at connecting stuff, right? Now, all of a sudden, I will only recommend the products that I can actually ship through my supply chain, right? Which is a really relevant and important thing. So that's a 1 + 1 = 3. And we start seeing this snowball effect. We're adding the N+1 application, the N+1 use case for graphs is easier than adding the nth one. And the N+2 is easier, even easier than N+3, right? And so that is really powerful. And marrying that up with the this this momentum around using knowledge graphs for AI, that I think is a really, really powerful, like a fertile ground to build a truly generational company, which is ultimately what we want to do at Neo4j.
Okay, Emil, it was a pleasure having you. Thank you so much.
Awesome. Really enjoyed the conversation. Thanks.
Thank you.